Alright, we are looking at 5 ways to shoot yourself in the foot with Python. So number one way is mutable default arguments. So as you can see, add item is the function here. The first argument is item and second argument is my list equals to empty list. So as you can see, list is actually mutable in Python. So here we have a mutable default argument which is defaulted to empty. And now if we add something, an item, mylist.append item, return mylist, this will create shared state. So for instance, list1, so we are calling this function add item apple, list2 equals to add item banana. So both of them invoking the default argument. So because they are passing just one argument, apple and banana. So if you print list1, it will give apple, but if you print list2, surprise, it will print, instead of banana, it will print apple, banana both. So the default list is created once and shared across all function calls. So call 1, it is giving empty to apple, and call 2, it is giving apple to apple banana. So if you make more calls with default argument, then it will keep on adding and doing stuff on that. So instead what we can do is add item, and my list equals to none. If my list is none, that means my list equals to empty list. So that we do within the body of the function, and then we do my list of append item, and finally we do the return my list. So that makes sure that my list is not shared across multiple function calls. The space is not shared. So another way to shoot yourself in the foot is late binding closures. So creating functions in a loop. So this is a classic closure trap. Each lambda will capture the same variable I, not its value. So functions equals to empty list for I in range 3. Functions dot append lambda colon I. What it was trying to do, it was trying to capture 0, 1, 2, but instead, by the time any lambda is called, the loop has finished and I equals 2 for all of them. So what is happening when we do the printf for f in functions, printf, it prints 2, 2, 2 instead of 0, 1, 2. So the lambda captures the variable I, not its value at creation time. So expected 0, 1, 2, relative 2, 2, 2. So instead what is you can do is capture the value using default parameter. This creates a new scope for each iteration. So functions equals to empty list for I in range 3. Functions will append lambda x equals to I colon x. Another way to do this is use list comprehension. Functions equals to lambda x equals to I colon x for I in range 3. Anyway, this is problematic for any programming language, modifying a list while iterating. So removing items, shift indices, causing the iterator to skip elements, etc. Lots of problems there. So the good way to do it, for example, list comprehension. Create a list, new list with only the elements needed. For instance, here numbers equals to num. For num in numbers, if num mod 2 not equals to 0, so it will be a new list. And removing items does not affect indices, we have not processed yet. Or we can also iterate backward. That's a good option for I in range length of numbers minus 1, minus 1, minus 1. If numbers I mod 2 equals to 0, numbers dot pop I. So it will iterate in reverse until it reaches 0. So shallow versus deep copy. This is interesting. Original 1, 2, 3, 4. List of lists. Shallow equals to original.copy. Shallow copy only copies the outer container. The inner lists are still the same objects in memory. So modifying an inner list affects both variables. So shallow 0.append 3, it will print original, will give us 1, 2, 3, 3, 4. So original, as you can see, the pointer 1, 2, pointer another pointer 2, 3, 4. Shallow pointer 1, 2, pointer 3, 4. So inner pointers are shared, inner space is shared, inner lists are shared, same pointers. So instead do the deep copy where which does it recursively. All you need to do is call import copy original equals to 1, 2, 3, 4. Import deep copy. All you need to do is this copy dot deep copy original. So copy is a library. All you need to do import copy and then call copy the deep copy function from copy. Alright, then we have integer identity confusion. A equals to 256, B equals to 256, print A is B. Will give true same object. Python caches small integers from -5 to 256 for performance, caches. So these values are cached. Beyond this range, in integer creates a new object. So this can lead to confusing behavior when using is versus equals. So if we just increment the value by 1 and try it with 257, it gives completely different result. So A equals to 257, B equals to 257, print A is B, it will give false. So in the case of 256, it gave true. So the workaround, always use equals to for value comparison. Print A equals to value B, so this will always give the correct answer. Since we are interested in value comparison, right? So anyway, so these are the top 5, but there are many other candidates out there to shoot yourself in the foot with Python. Alright.